Hello, welcome back to Advent of Code. This is day 11, Dumbo Octopus. So let's get stuck in immediately. You enter a large cavern full of rare, bioluminescent Dumbo octopuses. Cool. Cute. Okay, so that's a Dumbo octopus. Noted. They seem to not like the Christmas lights on your submarine, so you turn them off for now. Oh. There are 100 octopuses arranged neatly in a 10 by 10 grid. Each octopus slowly gains energy over time and flashes brightly for a moment when its energy is full. Although your lights are off, maybe you could navigate through the cave without disturbing the octopuses if you could predict when the flashes of lights will happen. Each octopus has an energy level. Your submarine can remotely measure the energy level of each octopus. So that's our puzzle input. Yes. The energy level of each octopus is a value between 0 and 9. Here, the top left octopus has an energy level of 5. The bottom right one has an energy level of 6, and so on. You can model the energy levels and flashes of light in steps. During a single step, the following occurs. First, the energy level of each octopus increases by 1. Then, any octopus with an energy level greater than 9 flashes. This increases. Then, any octopus with an energy level greater than 9 flashes. This increases the energy level of all adjacent octopuses by 1. Oh, including octopuses that are diagonally adjacent. If this causes an octopus to have an energy level greater than 9, it also flashes. This process continues as long as new octopuses keep having their energy level increase beyond 9. An octopus can flash at most once per step. Okay, so that's going to prevent the runaway effect. Finally, any octopus that flashed during this step has its energy level set to 0, as it used all of its energy to flash. Naughty octopuses. Adjacent flashes can cause up to earn a step even if it begins that step with very little energy. Consider the middle octopus with 1 energy. Yes. After step 1, it's because they all increase that energy by... Okay. Okay. I think I understand. Yeah, it just gives us a lot of example. And how big's our puzzle input? Oh! Our puzzle input's tiny. So, I was thinking, because if I come back to... what day was it where we did lanternfish? That was it. That had a similar thing of like lanternfish having an internal counter. In this day, it was like a counter. Was it increasing or decreasing? And then they would spawn new fish, and I ended up having to sort of create bins of fish for each of its different ages. And I was thinking, might have to do that for the Dumbo octopuses, but the puzzle input is so small, we might not need to do that. In which case, this seems fairly trivial, touch wood, to implement. So, as usual, we'll start off with the example they give us. And so I've got, let me come here, I've got our day 11 ready to go. Here's our day 11 function. What I'm going to do is I'm going to open day 10, because our code is actually quite simple to reading. Was it day 10? No, it wasn't day 10, it was day 9. It's going to be quite similar. So I'm actually going to come here and open our common. And this I'm going to hoist out into here. No, no. I said here. There we go. And because we're also wanting diagonals as well as the orthogonals, we would then have the so this then becomes northeast. I'm going to get rid of you. Then we have the east cell, then we have the southeast cell, south cell, we have the southwest cell, and we have the northwest cell. So this is obviously going to break our day 9. I think. I've also, between the last video, I've added in this assert into each of the days. So we've got a bit of regression testing now. So if I build this and run it, we should see day 9. Oh, so day 9 still works. I wouldn't thought that's the case because we're using we're using the Zelda account now, which is now going to be equal to 8, right? 0, 1, 2, 3, 4, 5, 6, 7, 8. So we actually sort of want a static int 32 we call this K orthogonal cells. This 4, that's going to equal to north cell, east cell, south cell, and west cell. Actually, this can be defined. Orthogonal cell count equals 4, right? So then that comes here, and then this becomes orthogonal cell count. Just I'm fixing day 9, get say, enum, cell direction I, so we actually want K orthogonal cells I. I don't like doing the K thing. I'm just going to call them orthogonal cells. There we go. And then yeah, this becomes orthogonal cell count, orthogonal cell count. If I compile that now, do we include the common? Yeah, we do include common. Syntax error. Identify orthogonal cells. No. Or S for static. Oh, I see. It needs to be. Yeah, I can keep it. I need to put struct here. No, enum. Static enum cell direction of orthogonal cells. Missing. What's wrong with that? I'm saying I'm missing a. Oh, don't need you there. Okay, that's working. So day 9 expected 902880. So we got the wrong result. Why? So then this becomes orthogonal cells. Let's compile you, run it. Day 9. Get adjacent cell index. I mean, this get adjacent cell index now can become part of our common, because we're going to need that as well. The only thing is, I'm going to call this out x and out I, out y. I32 in x, I32 in y. No, I don't like this. It's going to return. It's going to return a vector 2D. And it's gonna. We're going to pass in a struct vector 2D our cell, right? So this now needs to, I'm going to put this down at the bottom. So then we're going to have our struct vector 2D out cell. It's just going to equal our cell. Oops. And then if we're doing north, basically our out cell dot y minus equals 1, and we break. So let me copy this again, and I'm just going to make a comment of the original version, because I can come back to it. Yeah, so if I get rid of these, I can just say outcell.y minus equals 1 break outcell.y plus equals 1 outcell.x plus equals 1 and outcell.x minus equals 1. But we also now need to do the cases for our northeast cell, which is going to be just need to go through and do each of these. And finally, our northwest cell, which is going to be outcell.y minus equals 1 and outcell.x plus equals 1, and we can break. And then we return our outcell. And then this goes. So this just becomes get adjacent cell, and then in this case we also want to say like is cell valid, right? So we pass in our struct vector to the cell, and then our width and or vector to the map size. Yeah, map size, and then we can say like if cell.x is less than 0 or cell.y is less than 0 or cell.x is greater than or equal to map size .x or cell.y is greater than or equal to or map size.y. If that's true, then we return false, otherwise we will return true. So here, when we do get adjacent cell index, and I'm gonna move all my cell direction stuff down to just here. So get adjacent cell index, it returns our, well, we pass in our struct cave height map, call that HM. We get our cell I, which is I32, cell index, by enum cell direction and adjacent cell I, which is I32 out cell index. So essentially we want to get our struct, we want to get our vector, which is equal to, and you can see here it's vec 2D from 1D. So we pass in our height map, that size, and we pass in our cell index, and then we do get adjacent cell, get adjacent cell, and that you just pass in our cell and our direction, and then we can say if is cell valid, and we pass in our size, so that's hm size. If it is valid, we can return true, otherwise we return false, and we can say our out cell index is equal to vec 2D, we want a 1D from 2D, and again we pass in our height map size and our cell.x and our cell.y. This 1D from 2D, why do we not just pass in a vector? Why do we do that? That should really just be struct vector 2D. And then you just pass in the cell. And that compiles, and so we're still getting this with this. And the problem is our adjacent digits actually just need to be so we do just want to do cell.dir count. We just don't end up using not the best way to do this. The issue is we've got an array length 4 that we're storing our orthogonal ones in, but obviously our orthogonal enums go 0, 2, 4, 6. In which case this just becomes 0, 1, 2, and 3, which isn't ideal. Digit is less than each of these. This can still be orthogonal cell count. We need to do the same here, right? Adjacent cell I. Let's see if that works. So day 9 is still not really working well. Add all non-9 adjacent cells. So we're creating an adjacent cell of size 4 for each cell. We could have a bool is cell direction orthogonal. And you would return dir equals and then this becomes cell dir count. This becomes enum, again cell direction I, and then we just say like if not is cell direction orthogonal. Continue. Then we do the same here. And then these do become north cell, east cell, south cell, and west cell. So let's have a look at that. Compile U. But we're still getting this. Oh, why is that? Let's get adjacent cell. You pass in a cell or out cell. Is cell valid? We're checking if the X is out of the cell bounds. We're getting risk level equals 0, which obviously isn't right. So let's come to good old remedy BG attached to process. No, sorry, it's we want to run AOC, and I want to open day 9, and I want to find a low point and run it. So if I step over, let's have a look at cell I, which should equal to 0. Step over, let's look at dir I, that should be equal to 0. This should not continue. Let's step into get cell, adjacent cell index. So if I look at dir, that should be the north cell. So then if I look at what our cell is. It's 0, 0. And then if we step in to get adjacent cell, and we look at this, and we look at out cell, our out cell is 0, 0. We do -1, we return the out cell. Then we check if cell is valid, which should return false. And it sets that to 255. So does it ever actually get into here? Yes, it does. When dir is equal to 2. And our adjacent digits so far, obviously we only care about these because these are the diagonals and we're ignoring those. Step over, step over, step over. Then we should eventually get to here. As you can see, our digit, and then we look at our digit, which is equal to 9, but obviously there's still oh, wait, yeah, height map is a... So obviously there's something wrong with, let's look at input. Oh, I have to go to input day 9. So the first one should just be the first digit should be looking at that. We are reading the right input, right? Yeah, input day 9. So let me stop this and yeah, come back to here. Run it. When we step over, our digit is 7 and our adjacent digits is 255, 7, 7, 255, which if you look at here, it should be just 6 and 9. It's wrong. As in our adjacent digits north cell to 4, 6. So why are we getting 7, 7? Let's figure this out. So I want to know here and here. So we're looking at north. And we're setting the first one to 255. And now we're looking at our, let's look at our adjacent cell I 0. Well, that's obviously wrong. So step over this. That will return. Dir is now 1, which is the diagonal, so we should skip over that. Now it should be east. So let's step into this. Here we go. We can see up here, east cell. The cell should be vec 2D from 1D. Yeah, so our cell and our adjacent cell. East, it should be 1, 0, right? Yes. Is cell valid? Should be true. Ah, yeah, I can see the issue. I can see the issue. Sometimes that's all it takes, is a little bit of reading through. It should be returning adjacent cell here. If I now compile you and run it, day 9 is now giving the right result. So we can come back to day 10. Sorry, day 11 I mean. We're on day 11, aren't we? We also want to copy the day 9 read inputs. File F, U64, count, void user data. And you can see here, actually, this struct cave height map. I'm going to cut you out, and this is going to become, in again, our common. I'm going to put that here. These orthogonal cell counts can go because we don't use them anymore. And this now becomes basically a map of U64, right? Oh no, a map of U8. Yeah. And so if I come to replace, and I want to replace cave height map with map U8, did that work? So let's just check that still compiles. It does. And then if we come to our input helper, this day 9 read input can become something. So if I'm just going to copy for now. So this can be scan digit map. So this becomes a map. Count, scan, scan C. There we go. So we can get rid of day 9 read input, and then if we come down to here, this just becomes scan digit map. Let's compile U. Let's run U. Day 9 still works nicely. So let's come back to 11. And so we can do bool did read equals read puzzle input input day 11 dot text. We pass in our count, our input count. We pass in our map, which is a structure, so our digit map, and our scan digit map. And our we still need to allocate our numbers. Digit map dot cells equals digit map cells, our digit map. And then this can actually be, if I come back to common, I can sort of do struct map u8 map u8 alloc. And then I'm basically just gonna cut U. Actually, that can be count. Oops. Count. Call that map cells. And then we return the map. And then our equals there you go. Compile. I think day 11. Yeah, so this becomes digit map equals map u8 alloc day 11. So all these can go. This becomes our digit map.count, and that's now running. Okay, and then we can do our if did read if r, and then our input 11. Did we make a 11? No, we didn't. So we need to do our input day 11.text, and we need to give it our example day 11. Let's run this. So no errors there. Okay, so this should be fairly simple. So all that was just basically refactoring basically deduplicating our code. So we now got more common code between the days, which is nice. Oh yeah, this can now go as well. And if any more days come up in the future where it tells us to like read in a grid of digits, then we can do that. So there are 100 octopuses neatly in a 10 by 10 grid. Each octopus slowly gains energy over time. So the energy level of each octopus is a value. So let's just assert that. So I'm going to say assert equal our digit map dot count should be 100. Expected 100 got 101. Yeah, I remember this issue in the last time. I'm not actually sure why it's always one more. And if we actually come to our input helper, because our count starts at 0, right? Our count starts at 0. Where's that extra 1 coming from? Yeah, it says the count 0 here. Ah, okay, that works. If I say scan count equals 1, does not equal 0. Alright. And then I can say digit map width should be a 10 by 10. So if I say size.x and size y, again, yeah, we're not getting any asserts there, so that's all good. Right. So the easy case is just to, let's see, what output do we actually have to output? After 100 steps, given the starting energy levels of the octopus in your cavern, simulate 100 steps. How many total flashes are there after 100 steps? So without doing the sort of other octopuses making, and let's just call this our Octopus Map, because that's what it is. Okay, so we're gonna step, so to do one step, that is, we're gonna iterate through our octopus map. So for U64 octo-I octo-I is less than our octopus map count octo-I plus plus. We're going to say our octopus map cells octo-I it actually makes more sense to say cell I. We're going to increment by 1, and if our octopus map cell I is greater than 9, right? greater than 9 flashes, we say that the Octopus Map cells I goes back to, and our number of flashes, we're going to have a U64 flash count. We're going to increment our flash count. And then after one step, I'm going to say print line flash count equals percentage. Give it that flash count. So I'm going to run that. See, day 11 flash count equals 0. Does that make sense? Let's go to our input day 11. We don't have any days, right? So we then need to basically hoist this into a day. So I'm going to do void day 11 advanced step, and it's going to pass in our struct map U8, and that's going to be our Octopus Map, and it's going to return a flash count. So I'm going to do this, cut you, paste you in there. These are now pointers. Return that. And then we can sort of say for U64 day equals 0, while our day is less than 100, we'll say day plus plus, and our flash count is going to equal to day 11 advanced step. So we pass in our Octopus Map, I'm also going to say U64 total days equals 100. And then this can say compile that and run it. So day 11, after 100 days there are 1,000 flashes, which we know is wrong because now we need to handle the swapperoo. So it would be good to be able to also, if I come to common, print a map 8. So that's what I'm going to do here. I'm going to do void, I'm going to say map U8 print, and you pass in a struct map U8, pass in the map. And then that's just as simple as doing I guess we can do that in y equals 0, y is less than map.size.y, y plus plus. And then we're going to printf a new line here, printf a new line here, and then we're going to get our U64 cell index is going to equal to vec2d from vec1d, sorry, from 2d, and then we pass in our map size, and we pass in our cell, which our struct vector2d cell is just equal to x and y. And then we printf percentage %u, which is just going to be our map cells cell I. So I go to input day, I go to day 11. So each step we're going to do map UA print, and we'll just pass in the Octopus map. And for now, I'm just going to do 4 days. I'm going to print line. I don't know why I call them days, they should be called steps. Because that's what they call it. Total steps, step. Okay, so after 0 steps, after 1 steps, after 2 steps, after 4 steps, and I'm actually going to put that in there. So after 0 steps there were 0 flashes, after 1 steps. After 1 steps there were 13 flashes. Well, if there were 13 flashes, I would see 13 zeros. Which I don't see. This one I'm most confused about because there's no zeros yet, and we're getting flashes. Which I guess because really you should put that there. It's a ordering issue, so. After 1 steps, after 2 steps, yeah, no, that makes sense. Okay. So let's see how that compares to our advent of code. After step 10, there have been a total of 204 flashes. So we want to validate that. So basically we want to do assert equal i4 flash count. What did it say? 204. 10 step flash count. So right now that's going to fail expected 204, got 100. So we need to start considering the diagonals. So how do we do that? Well, come back to day 9 because that's going to have similar things that we want to look at. We now always want to say when that flashes, it increments all the other cells around it by 1. But each cell can only flash once per step. I'm thinking whether we need another data structure to store that, because an octopus can only flash at most once per step. So I could just check, like, I increment octopuses adjacent to it if their number is not 0, because that means they I'm not sure whether if an octopus is at 0 it means it's must have flashed this step. But I don't think that's true, but I'm gonna try it anyway. So basically, once an octopus flashes, we need to get all the adjacent cells. And to do that, we can sort of do for u8 do I equals 0, while do I is less than our cell do count. What we're going to do is get adjacent cell, and if you look at that, we've got to pass in our octopus map, our current cell, come back to common, let's look at our get adjacent cell. Oh no, we just pass in our cell and a direction. So we know that our current cell, I'm going to put that up here, equals vec 2D from 1D, and we just pass in our cell I and also our octopus map size. And I'll do I. Sorry, that needs to be vector 2D cell. So that works. So that becomes our struct vector 2D adjacent cell. We need to check if that's valid. If is cell valid, and we pass in our adjacent cell and our octopus map size. Then what we're going to do is our U64, our adjacent cell index, is equal to vec 1D from 2D, and we just pass in our octopus map size and our adjacent cell. And then our octopus map cells, cell I, increments plus equals 1. So then this becomes sort of a energized cell, struct map u8 octopus map, our cell index, So we want to say like if does not equal 0, then we're going to do energize cell I. And the way we do that is I'm going to copy you. So if that's greater than 9, so again, we have our U64 flash count equals 0. Our flash count plus equals 1. Our Octopus Map cell I equals 0. And then I need to cut you out. So we have a little bit of a recursion here. So this becomes day 11 energized cell. And then all of this can go. And our flash count plus equals energized cell. And we need to, yeah, flash count plus equals, we need to remember to return that flash count here. So when we advance a step, we're just going through all our cells and telling them to energize, which that does there, where we do the increment. So we do the increment, and then this is where we do we do our increment energy, flash when full energy, and then here we sort of energize adjacent cells here, and that's where we're going through all the different directions, checking if it's still within the map bounds, and then as long as it hasn't already been energized, we tell that to energize. So let's see how that fares. So after 10 steps, we expected 204 flashes, but we actually still only got 100. Let me just try that again. So let's go to our scratch. So as you can see here, this is before any steps. That should match this, which it does. And then after one step, so this is after one step, let's have a look at our after one steps. In theory this should still match. I'm just going to do a quick look, pass through, it looks good. And then after step 2, yeah, I'm starting to see differences between them. 8800747. Yeah, look, it's very different after 2 steps. And if we look at the number of flashes, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. 35 flashes after step 2, and here it's only saying 13. So I think the problem is just assuming that we can say if it's not 0. What we need is another array of cells where we can say, okay, you know what, U8 are flashed cells. And actually, not even U8, it can just be an array of bool, although I think that's still just bool. And we're going to use calloc this time, just so we set them all to 0, and it's going to be equal to Octopus Map count size of bool. And then we need to remember to free our flash cells here. Any flashes, this increases the energy of all adjacent octopuses by 1, including octopuses that this causes it also flashes. As long as new octopuses keep having their energy level increase beyond 9. An octopus can only flash at most once per step. So does that mean once it's flashed, it no longer increments? If that was the case, we would see a lot of 9s. There's an ambiguous step here, I think, where if an octopus has already flashed, can it still be incremented? And then it just stops at 9. Anyway, we need to pass in our flashed cells here. So this now takes in a bool array of flashed cells. So when we increment, what we can say is if our flashed cells cell I, that's true, we're just going to return early and return our flash count. So we don't increment it, we don't flash it, we don't. Or another way of saying that is and not flashed cells cell I, and then equals true. So let's run that. That needs to pass in our flashed cells. There we go. So let's run that. So So that's still saying after 2 steps there were 13 flashes. What's wrong here? We set this back to 0. I'm a little confused about tell you what, they do give us this more tinier example. So let's try on this. If I run that, oh, of course, because I need to disable these asserts just for now. So after 1 step, all these become 0, 0, 0, and these become 2, 2, 2. But why? This increases the energy of all adjacent octopuses, including octopuses that are diagonally adjacent. Adjacent flashes can cause an octopus to flash on a step, even if it begins that step with very little energy. Consider the middle octopus with 1. After 1 step... Oh, I see. So this flashes, and it increments all these to 2. This flashes and increments all these to 3. This flashes and it increments. Whereas this I'm getting 2, 2, 2, 2, 2, 2, 2. So when we tell it to energize the cell, let me just disable this thing for now. Oh, well, I'll disable it. Get adjacent cell. Is cell valid? Energize. So let's go to our good old debugging. Go to day 11. And we want to have a look at U. I'm going to get rid of all U. And let's run. Sorry, I need to get rid of U. Breakpoints, run. So our cell I is currently 6. So let's see, that's 0, 1, 2, 3, 4, 5, 6. So it's found the first 9. So we're going to step over and we're going to set that cell to 0. Why is it not coming in here? Let's just make sure that's properly compiled. Okay, our cell I is 6. Our adjacent cell now. So if I look at the cell, it's 1, 1, which is correct. This is 0, this is 1, is it? Yep. And then our adjacent cell, we're looking at 1, 0. Is that valid? It is. We're getting the adjacent cell I. So that should return 1. Yep. Oh, I now need to, okay, get rid of this line here as well. That might have been causing issues. Okay, it's looking a bit better. After step 2, we should get 1, 1, 1, 1, 1 in the middle. But we're actually getting... So that's a bit weird. So let's compile that, and let's just run that again. So cell 6, and if I do Octopus Map cells, cell I 10. Oh, of course. So it should now be 0. Our flash count is 1. We're going to go through all the adjacent cells. So we're going to look at 1, 0. Let's step in. I'm going to increment aha, 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 aha. I've seen another error that needs to say adjacent cell I. Let's have a look at this now. 1, 1, 1, 1, 1, 2, 3, 5, 5, 4. 2, okay. Again, it's close, but so we energize the adjacent cell. And what happens if I have a feeling it would just, you might end up in an infinite loop if I get rid of this. Flash cells, cell I equals true, energize adjacent cells. So this middle value only gets up to 9. I guess the way in which I'm doing it, I could So these all flash, and they should all increment this middle one by 1 after 1 step. So let's just do total steps equals 1. See that? And then yeah, because it's got 8 flashes around it, and then it should increment itself just by the advancement of time. So that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's cell 12. So every time, basically I want to go if cell I equals 12, I want to print line middle cell incremented, and then I want to say middle cell flashed. So it started at what did it start at? 1. So it incremented to so it incremented 2, 3, 4, 5, 6, 7, 8, 9. I want to know the depth as well. So I'm going to put in a U64 depth here. And each time we recurse, I'm going to pass in depth plus 1. And I can say depth is so we start off at depth 0. Interesting. One, two, three, four, 5. 1, 2, 3, 4, 5, 6, 7. So we go up to depth. What happened to depth 1? There's also a non-recursive way to do it, and that's to just increment all the cells and keep iterating on it. So essentially the way you would do that is I would iterate on all the cells. I would say, okay, each cell we increment by 1. And then once we've incremented them all by 1, I would say if Octopus Map cells cell I is greater than 9, then I'm going to say is actually equal to itself modulo 10. No, modulo. Is if I mod. Because if it was 9, it would go to 0. If it was 10, it goes, yeah. And then we say flash cells cell I equals true. And then again, I would iterate over all the cells and say if flashed cells, I would do the whole this whole thing. So if the cell is valid, I would then say Octopus Map cells adjacent cell I plus equals 1. Yeah, I can see here, these all increment to 0. But then eventually this flashes. You would expect all these then to be 1. So yeah, once they flashed, it's not just like they can't flash at most once per step, they then can't increment in energy after they flashed per step. So this also becomes and so let me try it again with the way I was doing it before, which was to say this and then is cell valid and not has it already been flashed. and sorry, and not the adjacent cell. So yeah, I think doing it this way is the key. So we're saying and not and then we tell all of them to flash, and we basically keep iterating this This is where our stack might come in useful, actually. So our stack of, so our struct, we're going to have two, yeah, we're going to have our struct stack, I'm going to call this our open list, and that's going to equal to stack alloc, and you know, for now I'm just going to put in 10 items, and it's going to be size of U64, because it's going to have our open list of cells. So I could do that here, actually. And then we're going to say stack push our open list U64. We're going to push cell I to here, and then this basically becomes while our open list.count is greater than 0. We're going to get the cell, so U64 cell I is going to equal to stack pop, pass in our open list U64. Right, that's how that works. SD type, and then let me just get U. Wait, what just happened? Get U, which is going to be Control X, Control V. So we're going to get the cell for each adjacent direction. Is the cell valid? And we haven't already flashed it. We're going to increment them and also check here if Octopus Map cells adjacent cell index is greater than 9. We will also do this. So let me get U, and then we push to the open list this adjacent cell. can mark it as flashed. Right. And then this will be stack free or open list. And we also want to increment our flash counts in both these cases. So we get rid of that. So here we do the initial energize on all cells, right? And then we do the iterative approach to adjacent cell overflow. Yeah. The only thing here is that this and this is the same, but that's a right flash cells adjacent cell. But that's fine. So let's have a look at this. Does that compile? It does. Aha. So it's kinda not right. After step 1, they should all be 0 in the middle, and it should be like 3, 4, 5, 4, 3, 4, 5, 4, 3. But we're getting not quite what we wanted. Do initial energize on all cells. So we flash the cells. So I'm going to also print our Octopus Map here. So you can see it initially increments all these, and then also these and these have been flashed. Let's also, once we've done this, this is now like an iterative approach, we can print it. So it starts off with this, then we run through and we increment everything. These have been flashed. Then we start to do all the adjacent stuff. So it's actually looked at this to begin with, because that was the last one put on the list, and it's gone through and incremented. Interesting how it hasn't incremented the middle one. Which is northwest. Is it just that our northwest is wrong? Yeah. God damn. Our northwest code was wrong. Because as you can see, this is after the initial run. Then this set here is incrementing all these by 1. But it's not incrementing south east. Y, X, southeast looks right though. Then it's incrementing all these. Again, it's not incrementing southeast. Why not? What's wrong with southeast? Southeast actually looks good to me. Outcell is the opposite of northwest. We're getting our Celdo count. If I is equal to southeast cell, I want you to print her. I'm just going to print that for now because I want to see in our RemedyBG here if we run so we're looking at cell 3, and our adjacent cell is 4, 5. Let's have a look. So column 3 is 0, 1, 2, 3. Row 3 is 0, 1, 2, 3. So we're looking at here. And our southwest should be row 4, column 4. Should be X4, Y4. Y is Y5. Y is it 4, 5? It's a 5 by 5 grid, that's correct. But Y's adjacent cell returning Y equals 5 when we're passing in a 3, 3. That's what I want to know. Are we missing a break anywhere? Yes, that's right. Missing a break. Okay. So now if we run it, let me get rid of the foo nonsense. That looks more promising. And then afterwards, yes, yes. That's exactly what we wanted. And I do prefer doing it this way rather than the recursive approach. It's just way easier to debug. So that can all go. This line can go. This line can go. And there we go. So let me get our thing here. Let me go to input day and delete U, paste U. And how many steps do we want to do? After 10 days, there we go. After 10 steps, there are 204 flashes, which is the same as what it says here. After 100 steps, there were 1656 flashes. So let's try 100. Make sure that says 1656 there. Run it and compile it, and correct. After 100 steps, there are 1656 flashes. So let's now try it with our puzzle input. Make sure, yeah, that's our puzzle input. Day 11. We'll re-enable our asserts here. Let's run it. After 100 steps, there were 1732 flashes. That is the right answer. So that is 1732. And this is day 11, step 1. Let's continue to part 2. Let's not continue to part 2. I will do part 2 another time because unfortunately I've run out of time today. But hopefully tomorrow I'll be able to do part 2. Cool. Thank you very much for watching.